Okay, I have just did the screen sharing. Is it visible now? Yeah, thank you, Chaitanya, thank you, Ratna. Okay, guys, we were discussing. Let us do a small recap, quick recap about the yesterday's topic. Okay, yesterday we have discussed about the instance of operator, or you can also say it as instance of keyword. Both are perfectly correct, right? So, instance of keyword is used for what? It is used for checking if you are creating an object and if you want to check if the reference variable is of what class type. For example, if you have created an object like aobj equal to new a, right, and you can create any number of objects for any number of classes. So b obj 1 equal to new b, right? You can create any number of objects. Okay, if you want to specifically check the reference of a particular reference variable of a particular object belongs to what type, belongs to what class type. And if you want to do that kind of checking, you can use what? Instance of keyword or instance of operator. Okay, so the moment you are doing this check, it is going to return what? Boolean value. If it is, if the matching type is found, you get true. If it is not, you get what? False, right? And also you have to remember that in order to do this checking, you have to maintain this inheritance relationship, right? So this is all about this was a discussion yesterday, and I have also elaborated few more things, and we have discussed a lot of problems. Okay, try to repeat it if you're not getting it, right? Today, why this topic was discussed? Why this topic was discussed? To understand the topic about downcasting in Java, right? This is one of the prerequisite. If you understand this, then understanding the downcasting is going to be very easy. Okay, so let us start understanding the downcasting. Let us start understanding what? We will start understanding about what? The typecasting. One of the typecastings in Java. First one is upcasting and second one is what? The downcasting. Okay, so the definition, okay, the actual definition, there is no actual definition. The actual theory could be like this. Okay, it is a process of converting a reference of superclass reference. If you convert the superclass reference to the reference of subclass, it's called upcasting. Superclass, when the superclass reference is converted to subclass reference, you call it to as, I'm sorry, did I say upcasting? No. When you convert superclass reference to subclass reference, it is called as what? The downcasting. Okay, so theory can be expanded like this. It is the process of converting a reference of what? A reference of superclass, reference of a superclass type to a reference of a subclass type. Okay, this process, okay, this mechanism is called as downcasting in Java. Okay, theory looks perfect and simple and concise, but a lot of understanding is required. We will try to debug the theory in the practical programs. Okay, are we good to start? Type S in the chat box if you are good. Can we proceed to the problem? Everyone type S in the chat box. I want S from everyone. Okay, good. See, now let us jump into the topic. Okay, so I will try to help you with the diagrammatic analysis about this downcasting conversion, right? So you need to understand this diagram first. Okay, what does it mean? What does the diagram mean? How does the diagram looks like? Let me introduce this diagram. Okay, let us say that let me take it in, let me increase the font size. Okay, if I have an x, okay, just imagine that x is of a class type. Okay, this is just like a kind of formula. Okay, when I create an object, okay, it is just like a formula. I will help you to understand this. Okay, next one is I have a type p and I have what the reference variable b. Okay, and I want to do the conversion. Okay, so I am using a typecast operator, and this is of what type? This of Q type. Okay, and I am taking this reference variable here in small letters, right? So I understand that you don't understand anything out of this. Okay, let me explain this for you. Okay, let me put it here. Okay, this is the procedure to do what? To do the downcasting. Okay, so the things that you see here, this X, think that X is a class, name of the class. X is what? X is the name of the class. And Y, this Y, especially this part, this is a name of the class. This is also the name of the class. X and Y are the name of the class, right? And P is also what? P is also the name of the class. P is also the name of the class, and Q is also the name of the class, right? And A is talking about the reference variable, B is talking about the reference variable. Okay, these are class types. Okay, so what can we extract from this particular representation? What are the things that we can extract it from the particular representation, right? Let me show it for you. Okay, let me remove this. 1 minute. Correct. See, let us try to identify the relation. So the relation between X and P, the relationship between X and P. Okay, X must be superclass to P. First we will understand the relation, then we will understand these things programmatically. X must be, let me decrease the font size for you. X must be superclass to P. Okay, the second relation is what? The relationship between X and Y. The relationship between what? Relationship between X and Y. Let me do something. Let me try to, okay, bring it here. Okay, the relationship between X and Y is Y is either same as X type or subclass to X type. Subclass to X type. Or X, I can say simply X. Let us keep it as X. Okay, this is a correlation between X and Y. Okay, let us find the correlation between Y and Q. Let us find the correlation between these two, Y and Q. Guys, if you have an option to let people in, you can do that. Okay, correlations between Y and Q. Okay, I can write it like in a way, Y must be either same as Q either same as Q or subclass to Q. You will understand this, don't worry. This is just a kind of formula thing. Just a kind of formula thing which you can utilize whenever you get a confusion. So don't say that it is already a confusion thing. This confusion will be cleared in a short period of time. Right now, the last, there are correlationship between what? P and Q. The correlationship between what? P and Q. Okay, Q must be either subclass to P or same as P. Q must be either subclass to P or the same as P. Okay, this is what you need to focus on. Okay, to understand the downcasting, these things are mandatory. I will explain you what are all things. Okay, first let us do something practically, then we will come back here so that this diagram will make more sense. Okay, so let me take two classes here. Okay, so this is our class. Okay, I have class A. Okay, and also I have class B. Okay, so here I want to do something here. Okay, I want to create objects. Okay, if I do the object creation like a equal to new A. Okay, this is completely valid, yes or no? Okay, let me use extends keyword. Okay, so a equal to new A, it is completely valid. So valid is a valid one. We know this already. You are creating an object for the parent class. Okay, so the reference variable can be of parent type, as well as the reference value can also be of parent type. No issues. Okay, when you do the object creation like this, you have access to the methods and the variables that is part of class A. Methods and variables. You have only access to the methods and variables that are part of class A, right? This is one advantage. Second thing, b equal to new B. When you do this, you are creating an object for the child class. Why child class? I have used extends keyword. When I use extends keyword, what does it mean? There is a relationship between class A and class B, right? I am creating an object for class B, which is a child class. When you create an object for the child class, what does it really mean? You have access to all the methods and variables of the child class, as well as you also have access to all the methods and variables of the parent class. You can inherit these methods and variables of class A to class B. So there is an advantage. Don't you think, sir? This is valid, but at the same time, you can access all the variables and methods of class B as well as A. But in the above case, we have access only to the methods and the variables of class A. Which one is advantage? Will you say this is an advantage thing or this one is advantage? Obviously, anyone with eyes can say, if I create an object for class B and if I assign the reference value as B, when I create object for the child class, right, I will be having a lot of benefits. I can able to access both the methods and variables of parent class as well as child class. So this is going to be an advantage thing. This is also valid. So what is the third thing? Third thing is I can create object for class B, right? And I can take a reference variable, okay, of what type. Reference variable can be of the parent type. This is the upcasting case. This part is talking about what? Upcasting. Yes or no? This is the third way of creating an object. When you have when two classes are in a relationship, when two classes are having an is-a relationship, okay, A and B are in relationship, you can create a reference variable of parent type and reference value or the object of child type. This concept is called as was upcasting. We have discussed these things. No need to keep any more discussion about this. Upcasting is completed. We have already done with this. Okay, when I do this, what are the advantages that I have here? Okay, compiler will come into the picture. Compiler will do what? It is going to do the typecasting implicitly. Okay, this part will be added by the compiler, and it is going to say what it is going to say. Here, Balaji, you have created an object for the child class, but you have placed a reference variable of parent type. So this is parent. This is parent. Okay, this is of child type. They both are not matching. Let me do the typecasting. How the typecasting is supposed to be done? It has to be converted to the parent type. This part is called as what? The implicit typecasting. It is completely valid. Implicit typecasting, it is completely valid. It will be taken care by what? Compiler. Okay, this part I am talking about. So both sides should be balanced. So A balance, B balance, A, B not balance. So I want to convert it to, it should be, the state should be balanced. It is balanced state. Okay, compiler is taking care of that. It is going to add these things. You don't see this, but these things are happening internally. This part is called as what? Upcasting. Valid, implicit. It will happen implicitly. It is valid one. It will be taken care by the compiler. If you are forgetting to take care of it, it will be taken care by the compiler. Okay. Benefits. You have access only to the parent class methods and variables if they are not common. We have discussed this already. And for specific, and if they are common, if the methods are common with the name, same name in both parent and child class. Okay. The child class method could be executed. Okay, this part is called as what? Upcasting. Okay, nothing. I was saying that let me take a method name here. Okay, if I want to take a method name like void m1, okay, this is the simple method I'm taking a method like void m1. Okay, and if you have the same method, okay, void, here also void m1, class B is extending to a. Why I am doing it like in a wrong way? Class B extends a, void m1. Okay, these are the both the methods are having the same names, right? And let me take non-common methods. This is m2, and let me take one more non-common methods. This is what? Let me take it as m3. Okay, so if I give this program to you, if I ask you to create an object like this, a equal to new a, okay, we have access to m1 method of a, m2 method of a. Okay, m1 method of a and m2 method of a, right? If I do the object creation in this way, b equal to new b, okay, I have access to this one, m1 method, m3 method and m2 method as well. So these two methods are same. M1 is same for b as well as it is same for a. So this will be given the top priority because we are going to execute this method. I mean, the main thread is going to look for a method in the child class. If it is not available, it will go to the parent class. So this will be executed. This can be executed. This can be executed. Totally, how many methods are there? M1, M2, M3. This is clear. Maximum number of methods we have. But when I do this, I will be having access to, specific A class method. What is a specific A class method? M2 is specific to class A. Okay, non-specific. Okay, this M1 is common to class A as well as common to class B. Okay, this will be, I have access to this. What is it? AC equal to new B. So when I create object, I have access to this method and I have access to this method. But I don't have access to this method. I don't have access. Restriction is placed for this specific method that is inside the child class, but you can execute only the common method that is in the child class. So this method is accessed, this method is also accessed, right? So this method will not be accessed. Why? Because both are common. Okay, this will be given priority. We have discussed this already. This is the upcasting part. Okay, now downcasting. Okay, what does the downcasting is really mean? Downcasting is nothing but when I use the child class reference variable. What is the name of the child class? B. When I use the child class reference variable, b obj object equal to, or I can say that when I assign the value of the parent class object to the child class reference variable. So this is child, this is parent. This is what? This is child, this is parent. This is not possible in Java. Okay. Ideally, a obj equal to new a possible, yes. Okay. Or b obj1 equal to new b possible, yes it is, right. A obj2 equal to new b, of course it is also possible, yes. But b obj3 equal to new a, this is not possible. This is what we are talking about. Downcasting is not possible. Not possible by the compiler. So we need to do some kind of manipulation. You need to do what? You need to convince the compiler in such a way that compiler will consider your request. That's what we are going to do. Explicitly, I mean implicitly is not possible. It is possible explicitly. For that you need to do some modifications. This is possible implicitly. Compiler has no issues. Possible implicitly. Possible implicitly. Not possible implicitly, but plausible explicitly. How we are going to design, how we are going to manipulate this code in such a way that the compiler will be convinced. That is what we are going to discuss. Right? So let me remove all this code. Okay, let me remove all this code. Okay, and we do not want to deal with this also. Okay, let me remove all this. Now the program is very simple. Class A, class B, and we have a test class. Okay, so what does it say? See, now I am taking three cases. I'm taking three cases. Case study. We'll do some case study. First case study is a equal to mu a. Okay, then I'm trying to do what? I want to assign this parent class reference. Okay, this is parent class reference variable. This is parent class reference variable. I want to assign this to the child class type. BB equal to internally you are doing what? You are doing something. What is that something? You are taking this reference variable of what type? Of parent type. Okay, A is of parent type, and you are assigning this to the child class. You are asking the child class to hold the reference of the parent class. What you are doing? You are asking the child class to hold the reference variable of the parent class, right? You gave a big responsibility. You have given a big responsibility to the child class to hold the reference variable of the parent class. Okay, so when I try to execute this code, okay, see what will happen. Okay, right. Okay, let us try to do the compilation as well as execution. Java cd space Java 3. Okay, Java C space, what is it? Test.java. Okay, it says, see, we are getting compilation error. Incompatible types A cannot be converted to B. What does it really mean? Child class reference variable cannot handle, okay, cannot handle the parent class reference variable. You cannot do this. So we tried. Okay, what did I just say before? I was saying that it is not possible implicitly. We need to do some modifications. So that we will be able to convince the compiler. Compiler is not convinced with this modification. No issues. Okay, this is case one. We will also do few more research. We'll try to convince compiler. Okay, let me take this as case one. Okay, this is case one. Okay, so our case study, our research and development has failed because when you try to do this, compiler is not happy with the code. What is the status of the compiler? What does the compiler says? It is directly giving compile time error. Okay, what is the actual error that we are getting it here? Right, it says clearly line number 14, not compatible. I'm not convinced. Okay, let us do the another case study. Okay, let us do the another case study. So case study to this one. Okay, so here the reference variable is of A type, right? Okay, I want to convert. I want to do the typecasting. Oh no, I am using what? I am using the typecast operator. Focus here. I am using the typecast operator, okay, to cheat this. to cheat this or to balance the LHS and RHS. I'm typecasting, I'm converting this reference variable which is of A type. I want to do a conversion like, no, it is not A type, convert it to B type, so that LHS and RHS are equal and they are completely balanced. Good, it is good. Now we will try to do the compilation now. Okay, now let us try to compile the same code. We did some research and we are trying to convince a compiler, right? Java C space test.java. Compiler is satisfied now. It is not throwing any error. No compile time error. Okay, let me copy this code. Okay, and as part of our research and development, okay, what we did, okay, this is what case 2, right? Case 2, this is our code. What is the status? What is the status? Okay, no compile time error. So we have convinced the compiler. Okay, then what about the status of the runtime? Execution, compilation is completed. We do the execution, right? So for the execution, we are getting an exception. Compiler is, we are able to cheat the compiler, we are able to convince the compiler, but we are getting a runtime error. What it says, cast exception, A cannot be casted to B. Even though you are trying to convince a compiler, I will not be convinced. The main thread is not convinced now. Main thread is identifying. You have did some manipulation, you try to convince the compiler, but as a main thread, I am responsible not to execute this code. Let me throw an error, cast exception. Why we are getting this error? We will analyze this. Okay, why the main thread is giving this error? So what we are getting, no compile time error, but runtime error. Okay, what is a runtime error? This is a runtime error. Class cast exception, right? So literally, so this A is again of what type? This A is of what type? New A. Okay, even though this reference variable, okay, you are trying to convert this reference variable to B type. Okay, the value that this reference variable is holding is A type. Okay, internally you are able to achieve this, you are able to convert this, satisfied. But if you do the deep focus, if you do the deep research, this is being the same. Again it is new A, again it is of A type. Okay, the problem is with this one, the problem is with this new keyword and with this A constructor. Are you getting this? So you are saying A is of A type. I mean this reference variable is of A type. You are trying to convert the reference variable, but you missed the object part. But object part is still what? It is holding the object has been created for the A class itself. Right? You have taken care of this part, but you have forgotten to take care of this part. This is the deep research. Okay, this research has been done by the JVM thread. Okay, JVM thread says, okay, even though you do this, internally it is holding A itself. I can able to convert this, but it cannot be converted. This one part you missed to convert this. So I will do what? I will give the exception like class cast exception. Okay, I can say that. No. So the question can be like, when you will get the class cast exception in the typecasting in Java, right? So when, please be informed that when you try to typecast the reference variable of superclass type to the subclass type and assign it to the subclass reference variable. Okay, will there be any compile time error? There will be no compile time error. We have convinced the compiler successfully. There will be no compile time error. However, you will get the java.lang.ClassCastException in the runtime, because the reference variable is converted, okay, but not the reference value. Reference value remains the same. Sometimes you see, guys, compiler is not clever enough to identify the runtime issues. Okay, so every time when you take a Java code, okay, there are two parts. One is the compilation part and the runtime part, execution part. Compiler means compiler, runtime means JVM will come into the picture. Okay, the problems that is not identified in the compiler, or the problems that is that is not taken care or focused in the compilation time, definitely that problem will be a problem in the runtime. Compiler is satisfied. Why compiler is satisfied? Because you are doing it correctly. You are clever enough to compile, convince the compiler. You are just doing the typecasting. It is okay. Okay, this part is typecasted. Reference variable is typecasted, but this part is not typecasted. This is something that that we missed. The compiler has missed this. This is identified in the runtime. That's why we got exception. Okay. Case 1, we are not able to convince the compiler, but the case 2, at least we were able to convince the compiler, but not able to convince the JVM. But there is another case, case 3. So we need to focus on case 2. Okay, and we need to do some manipulation. So when I take this case 2, we have an error. Why we have an error? Just think deeply. Okay, this part is giving us an error. This part is okay, but this part is giving us an error. Instead of doing this, if I change it to B. Now, if I run this code, I will not be having any compile time error, any runtime error. Let me run this code. Okay. So, no compile time error, no runtime error. Status is cluster clear. I have just changed it because of this only runtime is giving error. Because if I do a runtime is identifying this. Even though you are trying to convert this reference variable, which is of the parent type, to the child class type, but you missed this part. Still, it is holding the object of the parent type. It is giving us the clear instruction. So what I did, because instead of keeping the object for the parent class type, keep the object of the child class type. Now you perform the compilation and the execution. JVM has no issues, compiler has also no issues. Both part, they don't have any issues actually. So where, okay. Case 3, okay, what is it? Status. There will be no compile time error and no runtime error. Okay, from the case 3, I can conclude that, okay, we have achieved downcasting explicitly. We have achieved downcasting. How explicitly we have achieved? Okay, see, we have struggled a lot to understand this downcasting. Why? Because upcasting is an easy concept. Okay, see, look, go back to the code. So this is easy. This is a equal to new a. Okay, there is no casting here. They are straightforward. B equal to new b. No type casting here. A c equal to new b. This part is upcasting. Okay, and this part is talking about downcasting. This whole part is talking about. Since the variable names are same, let me take it as d and let me take it as e here. Since it is d, this should also be d. Okay, this is what? No casting, upcasting, downcasting. You require you did a lot of manipulations to achieve downcasting. You required the upcasting as well as from the upcasting you did something, you did a conversion, use the typecast operator to achieve what? Downcasting. Now this is completely balanced. This is what? Completely balanced. These two lines are talking about downcasting. Okay. Okay, sir, everything is good so far. Okay, so what are the advantages that we do have with the downcasting concept? What are the advantages that we have? Why one has to learn this downcasting? We are happy with this part. We are also happy with this part. We are also happy with this part. Why we want to learn this? Okay, I will give you the small program for the for the actual advantages. Okay, there are several scenarios where downcasting is particularly preferred. Many scenarios are in the real-time application. A very important topic, downcasting. It cannot be achieved implicitly, it can be achieved explicitly. So you need to remember these three cases: case 1, case 2 and the case 3. Okay, shall we jump into the program, real-time program? Yes, no, everyone? Don't worry about these things. We will be using these things in the polymorphism concepts. Okay, so again these things will be repeated. I am guaranteeing, I am giving you that guarantee. So don't ever think like you're not getting it in the first run. Okay, the first attempt. These things will be discussed. Okay, now let me open this Eclipse editor. Okay, let me write a new Java program. Okay, file, new project. Project name is, I want to create the project name as simple, or let me take the project name as downcasting. I'm sorry, it should be Java project. Okay, and name of the project is downcasting, right? And next, finish. Focus here. This programming part will give you some goosebumps. New, it will give you a lot of maja. Just wait and see. Package com.test. Let me, you can take any kind of package here. I can say simple. I'm taking package is not meaningful, forgot about that. Again, you open you created a package, and inside the package you need to create a class. Okay, I'm directly taking the main class. Okay, so the name of the class is driver public static void main. Okay, I hope the screen is visible for you perfectly. Okay, now you see guys, I have a main method here. Okay, I want to take two classes here. First class name of the class is flower. Okay, I have a flower class. So let us okay, first flower is rose I have. Okay, second flower is what is the name of, I don't know much flowers name. Okay, lotus, let us take. Okay, three classes: flower class, rose class and lotus class, right? So rose is a flower, yes or no? Rose is a what? Flower. But Java cannot accept this, even though it is a is-arelationship. Instead of using is here, you can use extends. Relation is there, flower and rose. There is a relation, direct relation is there. Likewise, lotus is a flower, right? So you cannot use is a, even though it is is-arelationship. The word is a has come from this. Okay, when you are dealing with the is-arelationship, this is how the is a has come. Okay, so extends, right? So inside the loss flower, I am taking a method. Okay, one common method I am taking, void L. Okay, system.out. System.out. Println random smell. Okay, and I want to take the same method name inside the rows. Okay, here I am saying a rose smell, right? And I am taking the same method name inside the lotus. So here I am taking lotus smell. Okay, we are just trying to build the code slowly. Okay, and I want these three methods are common methods. Smell. Both methods are having the same name, same return type, so they are common. Okay, now I want to take a specific method that is specific to flower. Okay, void what I can say here is specific to flower. Void state, void purchase, right? System.out.println in the market. Okay, some specific method with respect to rows, void price. Okay, system.out.println. So what is the price of a rose? I don't know. Let's take it as the price is maybe could be 10, isn't it? The price is 10 rupees. I'm not sure. Okay, and let us for load specific to lotus void purchase. Let us take the place. So lotus, they always bloom inside the ponds or lakes. Okay, if I give this code to you, okay, this code, okay, if I give this code to you, now can you tell me what kind of inheritance relationship is there between these three classes, lotus class and rose class and the flower class? What kind of inheritance relationship is this? First try to identify the inheritance relationship. Anyone can answer this to me? Is it single inheritance or multi-level or multiple or hierarchical or hybrid? Chaitanya says multi-level. What about others? Ratna Kumar says hierarchical. What about others? Want me to show the program? Okay, let me show it for you. Multi-level. No, hierarchical, guys. Why multi-level? One parent. Okay. Rose is extending to flower. Okay. Lotus is also extending to flower. Okay. One parent, two children. Flower is a parent and flower has two children. Rose is one of the children. One of the children and lotus is one of the children. Why multi-level under hierarchical inheritance? Keep it in mind. Never ever mess with this relationship. Okay. Whenever you see any code, you find any extends keyword, first thought has to come. You need to identify what kind of relationship between two classes or three classes. Okay. Okay. Think and say. Don't just give the answers. Okay. There might be some confusions. I understand that, but try to understand how many parents are there. If two classes are extending to same parent, blindly say it as hierarchical. Two child are extending to same parent. Okay. Now our understanding. What is the purpose of discussing about this downcasting? Okay, now if you see, guys, if I create an object for lotus L equal to new lotus, right? Lotus is of course a child class of flower. Okay, so I will be able to access, okay, three methods at a time. L dot smell, right? And L dot, what is it, place, right? And L dot, what is the another specific method, purchase. Okay, that is an advantage when you create an object for the child class, right? And if you use the child class reference variable, you can call all the methods of parents as well as child, right? So think, okay, L dot smell. When I say L dot smell method is there in the lotus class. Of course, same smell method is there in the flower class. Both are same. So the priority will be given for the lotus class because the reference variable is of lotus class. Right? That's why we are able to call three methods at a time. If I run this code, lotus smell, ponds and lakes, market, respective methods has been executed, right? So when I do the object creation for flower, okay, this is flower. Okay, flower. Now this is breaking. We are getting so if you see this red color line under, I know red current line is under place. You cannot access the place method because place method is part of which one? Place method is part of Lotus class. You cannot access because object is created for parent. Only the flower class methods are able to be accessed. One is smell, second one is purchase. Right? This can be accessed, this can be accessed, this cannot be accessed. That's why you are getting this compile time error. So see, you are able to see a kind of error mark here, right? Let me remove this. Okay, and when I do the object creation like this, flower obj equal to new Lotus. Okay, so when I do the object creation like this, okay, firstly it will, control will directly jump to the flower class because see, this is subcasting flower class. How many methods are there in flower class? There are two methods in the flower class. Okay, one is the smell method and second one is the purchase method. Okay, and what is the reference value that we have? Lotus is the reference value. What it will do, it will try to check if the smell method is available in the Lotus class. Yes, there is a smell method in the available Lotus class. Okay, this method will get executed, right? So when I call l.smell, okay, so Lotus class spell method will be executed. So this is overriding concept. We will discuss this in the polymorphism, right? I can also call l.purchase method. L.purchase method because this is of the parent class. This is also called, okay, but it will check if the purchase method is there inside the Lotus class. No, it is not there. So this gets executed. But I cannot call this place method. It is directly specific to child class. Methods I cannot call. But if you find any method that is common in the parent class, okay, this can be called. This will be, given as a priority. Making sense? This is upcasting concept. Okay, but downcasting, we are talking about downcasting. So what is an advantage? Okay, sometimes you will be in a situation, okay, in the runtime you are allowed to create an object like this. Okay, you are allowed to do the upcasting, but you need to call a method. You need to call this place method. Try to understand this question. Okay, this is of Lotus class, this is of flower class. Lotus flower. With this reference, I can able to call l dot what is it? These two methods I can call smell and purchase. So when I say smell, okay, when I say l dot purchase, okay, smell method, okay, control the JVM will try to look for the smell method in the flower class. Okay, smell method is there. At the same time, it will also check if the smell method is there in the child class, inside which is what? Lotus is also there. So this will be executed. Secondly, you can call l.purchase. Okay, control will try to identify the purchase method in the flower class. Purchase method is there. It will also try to check if the purchase method is there in the child class. It is not there. So this method will get executed. Thirdly, if you want to execute the place method which is of Lotus class, I try to do this. Okay, I am getting an error here. Error stamp is there. See, it says something, a red line is placed under this place. It means it is not possible to call. It's not possible to call this method because visibility is not there. But I want to make it possible. It's not possible. I want to make it possible. What is the solution? Are you getting my question now? Everyone, are you getting my question? Yes, no? Do you want me to repeat? How about everyone? Darshini, Shashwant, Venkatesh, Chaitanya, Raghunath has responded. What about others? You want me to repeat my question? Are you getting my question? Answer. Yeah, see, okay, so I want to execute this method. I want to call this method, but I cannot if I am asked not to change this object creation line, but still I want to call the place method by using this reference variable. By using what? By using this reference variable. It is not happening. I'm getting an error. I cannot run this. Okay, I can call smell. I am allowed to call purchase because they both are part of flower method, right? And smell method is available in the Lotus class. I mean, they both are part of flower class, and the spell method is available in the Lotus class. So if that method will be executed, overriding concept. But purchase method is not available in the Lotus class, so that is going to get executed from the flower class. But place method is specifically part of Lotus class. We are not able to call that. I want to call that. For that, what I need to do? I need to get help. What I need to do something. Okay, I need to get help from the downcasting concept. Okay, I need to do what? Downcasting. What I will do? I have the reference variable L. Okay, I will take this reference variable silently. I will take this reference variable. I will typecast this reference variable to what? I will typecast this reference variable to Lotus type. Okay, and I will use object reference value Lotus. So this is downcasting. So this is what? Downcasting. Okay, I want to use this reference variable. By using this reference variable, still I would like to call what method? I would like to call this place method of Lotus class. Okay, directly I am unable to call. So I am doing a manipulation. I am doing what? I am doing downcasting. I did downcasting. Okay, converted this reference variable to the Lotus type. Okay, and the assigned it to what? Assigned it to the reference variable of Lotus type. Okay, now I can call with this by using this reference variable, by using this downcasted reference variable, I can call this purchase method. Okay, if I run this code, Lotus mail, I did not say this. Not purchase. What is that method? Place method, right? Place method. Okay, if I run this code, Lotus mail, market, fonts and legs, right? So look at the now see, let me remove all this. Okay, somewhere some people in the runtime, they follow something, they pass some kind of object reference values here. This time it could be Lotus, next time it could also be rows, okay, even though if it is Lotus or if it is rows, okay, I want to extract the specific method. If it is Lotus, I want to extract the specific method, that is place. If it is rows, I want to extract the specific method, which is price, right? How can I achieve that? Okay, I can use instance of operator here. I can use what? I can use instance of operator. What I'm doing a conditional check. If L is instance of Lotus, I want to do what? I want to extract the specific method of the Lotus class. What is the specific method of the Lotus class? So this is the Lotus class. This is the specific method. I want to extract this method. What I can do? First I need to do what? Directly I cannot extract. I need to typecast it. Okay. If this is returning true, I am going to do a typecasting. I will typecast this reference variable of to what type? To Lotus type. Okay. And I will assign it to what? The Lotus reference variable. Okay. Now what I can do? Now I can do obj dot place. Okay, now I am using another statement, else if. Okay, if L is instance of, if L is instance of, we have rows class also, right? We have rows class also. If L is instance of rows, okay, I want to convert this to rows by using this reference variable. I want to convert it to what type? I want to convert it to the rows type. Okay, I want to assign it to a variable of rows type, downcasting. So this part is talking about downcasting. Okay, so by doing this, I can able to get access to the specific method of Lotus class. By doing this is also downcasting. By doing this, I can also able to access to the specific method of rows class. What is the specific method of rows class? Price is the specific method of rows class. Here I can say obj dot price. Else, if these two conditions are not valid, system, okay, I want to access to the specific method of flower class, which is purchase. Is what? Purchase. I will do the tracing. Don't worry, I will do the tracing. Okay. Now you see here I am using new Lotus. I am using new Lotus. Right? If I run this code, ponds and lakes. Specific method of the Lotus is getting executed. Instead of new Lotus, if I say new rows, right, I will be able to extract this, execute the specific method of rows. The price is 10. Okay. Instead of rows, if I use flower itself, okay, specific method of flower will get market. Okay, we are able to, okay, these are the common methods. Smell is a common. Forgot about the common methods. If you ever add to extract the specific method of a particular class, okay, purchase is a specific method of flower class, price is a specific method of what class? Rose class. Place is a specific method of what class? Lotus class. And you are also told not to change this object reference. Okay, object reference should always be in the form of casting type. In the runtime, if someone is passing new rows, okay, the specific method of new rows can get executed. Okay, so this can also be imagined like this, guys. Okay, let me do a small manipulation on this code. Okay, this code can also be imagined like, let me okay, I'm taking a static method here, public void, okay, specific method. Name of the method is specific method. Okay, here I want to, here it is going to take the flower type as reference, obj. Right, inside this I am placing the code. Right, so I need to change this as obj. Okay, obj. Okay, obj1 duplication is there, obj2 duplication is there, obj1 obj2. Okay, this is what, this is also, this is L itself, huh? Okay, nothing I did. Okay, now you see, you might be thinking why I need to do all this. I can create object for the respective classes individually. I can access to those methods. No, that is not the case. Sometimes you might be getting a situation like there can be a method. Okay, this is the method. Okay, in the runtime, okay, the the specific methods. Okay, there are several scenarios where where this particular specific method, okay, this method can accept a super class type as a parameter. Sometimes there will be a situation, you will encounter a situation where the specific method is going to accept some parameters. Thank you for rejoining, guys. Okay. Okay, shall we start? My screen is visible, isn't it? Okay, sir. Okay, Chaitanya. Okay, what I was just saying. Okay, sometimes we will be in a situation. Okay, sometimes there will be a method. Okay, this method is going to accept a parameter of the parent class type. Flower is what? Parent, right? Flower is what? Parent type. Okay, so by passing a kind of reference, object reference, so you are going to pass this. Okay, by passing a kind of object reference, you need to extract the specific method of the child classes. Okay, this method was designed in such a way. Okay, this is a method, it is designed in such a way this is going to accept only one parameter. Okay, but if you look at the parameter flower, it is accepting what? Flower. What is a flower? Flower is of what type? Parent type. Flower is parent. By using this parent reference type, you should be able to access the specific method of rose class as well as the specific method of lotus class. Then what you are going to do? Then downcasting. Then you do what? You do downcasting. Okay, you accept whatever the values are. Okay, so me as a end user, I might be passing lotus. Yeah, I might be passing a lotus, right? So I will be calling the specific method. Okay, let me do this. Okay, so by calling this specific method, this is a static method. I can use the method name directly, but I need to pass what? I need to pass the flower object. Flower object is what? L. I need to pass a reference variable here, L. Okay, in the runtime, I am able to pass lotus. Okay, if I pass lotus, my intention is to get access to the specific method ponds and lakes. Okay, in the runtime, I will be passing rose. Right, my intention is to get what? I need to execute the specific method of the rose class. Price is 100 rupees. In the runtime, I will be able to pass the flower itself. I need to execute the specific method of flower class itself. Market. Right? So in the runtime, there could be a method. The method is designed in such a way that it is going to accept a parameter of the superclass, accept the reference of the superclass. By using this superclass, you are asked to extract the specific method of the child classes. Okay, first what you will to see? Flower. Okay, there is a flower class. Flower class as what? It is a parent to rose class. It is also parent to lotus class. It has two children, rose and lotus. Okay, so with the flower, by using this reference, it is ideal, it is appropriate that you can access smell method as well as purchase method. But you want to access to the specific method of your children. Rose is your children, you want to access the specific method. Price. Lotus is your children, you want to access a specific method. Place. What option you are going to choose? What are the manipulation that you are going to do? In that case, downcasting is going to help you out. You will do downcasting. Each and every, you will do a conditional checks and you will do what? You will do downcasting. You downcasted here. By using this reference variable, you are able to access the specific methods. That's why you want to understand about instance of operator. Okay, if this is giving true, for example, if you are passing the reference L, okay, L is of what type? L is of new flower, right? So this L is passed here, right? It will check if L is instance of lotus. No, L is not an instance because L is instance of flower. Okay, this condition will fail, this condition will also fail. Okay, when two conditions are failed, obviously the third condition will be true. Okay, this gets executed. Okay, now when you pass rose here, it will check. Okay, this L is being passed to the parameter of specific method. Okay, now this rose is of what type? New rose type. Okay, no, L is going to be instance of lotus. No, it is not. L is going to be instance of rose. Yes, it is. So this method will get executed. You got access to the specific method, right? So when if I had to do the tracing for this, okay, let me do the tracing so that you people will get much comfortable. Okay, After doing this tracing, you look at this about these internal conversion things. Okay, you will understand. Okay, this is our code. Wait guys, it's not even spacious. Right, okay, this is our code. Let me separate this main method so that you people have better visibility. Okay, now you see, let us do a small diagram. Okay, I have one class, another class, and I have another class. Okay, I am using extends keyword. Okay, this one is extending to this one is extending to this. Okay, by looking at the structure, it should be in a position to say that this is talking about the hierarchical inheritance. Why hierarchical? So we have a flower class. Flower class has two children. Flower class has how many children? Two children. This is rose is one of the children, and lotus is one of the children. Okay, each and every class has some methods. Okay, let us try directly jump into this main method. Okay, so this part is talking about what? Upcasting. We are performing upcasting to do the downcasting. Okay, and we are calling a method here. Second instruction is main method. Only two instructions are there in main method. So when you take this as a main method as a whole, there are two instructions. One is the object creation instruction, which is upcasting because parent object, child reference. Second one is method call. So which method will be called? Specific method will be called, right? So the control will jump from here to here. This method will be called. What you are passing? You are passing L. L is what? New rows. You are passing what? New rows internally. Reference of L, new rows. Okay. So you are passing new rows here. Which if block will get executed, this will be skipped because it is of lotus, right? This will not be skipped because it is of rows. Okay? The object is matching, so this if block will get executed, right? And what you are doing inside the block, okay, you are doing the downcasting. After doing the downcasting, you are able to get an object reference. By using this object reference, you are able to get access to the specific method of the rows class. Okay, so this method is accepting the parent type and asking you to what? You should, asking you to do some manipulation so that you will be in a position to access specific methods of the child class types. You pass new rows, this is getting executed. Okay, instead of new rows, if you pass, okay, if you change this flow, instead of rows, okay, if you do lotus, new lotus, okay, obviously in the method call, new lotus will be passed. Okay, instead of new rows, here new lotus will be passed. Okay, new lotus is instance of what? This condition will get executed because this is what instance of new lotus. This will get executed. This lotus, you're doing the downcasting by using this reference type as lotus. Then you are able to call the specific place method, which is part of what class? Lotus class. Okay, when you pass flower, okay, you are able to get a specific method of the flower class, right? Try to do some practice. Okay, this is what the downcasting is. No worries, there is a concept called polymorphism. We are going to start it from tomorrow, right? You will get a lot about this. Okay, we are going to use this option very often. You will get a lot of things about this, right? This will make more sense in the future topics. For now, just try to write this code from your end and try to perform the execution. Things will make a lot of sense. Isn't it? Is there any questions for me?